Okay, so welcome back again, everyone. So in this recording, we're gonna take a look at the another objective that we have on this section 11.1, which is the construction and the interpretation of the confidence interval for the difference between two population proportion. So this is gonna be another objective, right? So after we talk about the hypothesis to compare two population proportion using independent sample. Now we're going to take a look at the construction and the interpretation of this confidence interval to estimate the difference between two population proportion using independent samples. Okay. So let's talk about the requirements and then the formula that we might use it to construct the confidence interval to estimate the difference between two population proportion. So construction of 1 minus alpha times 100% confidence interval for the difference between two population proportion P1 minus P2. So in order to construct a confidence interval for the difference between the two population proportion, we must have the following requirements. And then the requirement for this construction of the confidence interval will be similar with the requirements of the hypothesis. Yeah. So make sure that the sample gonna be independently selected, and then they're gonna be simple random sample. So this is gonna be similar requirement with the hypothesis. The second requirement, N1 times P1 hat times 1 minus P1 hat have to be more than or equal to 10. Yeah, so the P1 should be in the parenthesis. Yeah. So 1 minus P1 hat. Yeah. Okay, there you go. And then N2 times P2 has 1 minus P2 has have to be more than or equal to 10. So you want to make sure this condition is true. So the distribution will be approximately normal or normal, right? Now the third requirement that each sample size is no more than 5% of the corresponding population. Yeah. So you want to make sure that each sample size is no more than 5% of the corresponding population. So that's going to be the three requirements that we have, right? So now after we check the requirements, if they are good, then we are ready to do the construction of the confidence interval. So the confidence interval will include the calculation for the lower bound. So what's the calculation for the lower bound? So this is going to be the calculation for the lower bounds, right? So we're going to take the point estimate with a P1 has minus P2 has. So this is the estimation, the point estimate for the difference between the two population proportion, right? So P1 has minus P2 has minus the margin of error E. And this is the calculation for the margin of error E. The z sub alpha over 2, the square root of P1 has 1 minus P1 has over N1 plus P2 has 1 minus P2 has over N2. And then the upper bound is going to be kind of similar idea. We're going to use in the point estimate P1 has minus P2F plus the margin of error E. Yeah. So plus the margin of error E. So in those two calculations to be clarified, so I'm going to say that the calculation with the margin of error is calculated by this formula is equal. There you go. So this is the calculation for the margin of error E. So that's the calculation for the margin of error E. Okay. So in this calculation, I hope you guys remember how we calculate z about 5 over 2, right? We're gonna use the inverse norm. I can show this calculation one more times, or you might go back to chapter 9 and take a look at the critical value that we have corresponding with the given confidence level. Okay. So that's the formula that can help you to calculate the lower bounds and the upper bounds of the confidence interval. We actually do have a shortcut that you might use it to double check the answers or use it to get the answer quicker with the two proportion z interval. So the shortcut that we might use it is the two proportion z interval. So when you're using this shortcut, you need to put n1's x1, n2's x2 in the calculators and then select the confidence level. You might input as a decimals or percent. They will accept either or. And then go down to the calculate. So after we got the answer for the lower bounds and the upper bound either by using the formulas or from the shortcut, then we're going to wrap up this question by using the interpretation, right? So we are how many percent confident that the proportion, the difference between the two population proportion will be between the lower bounds and the upper bound. So based on the answer for the confidence interval, we might actually get the same conclusion for the hypothesis. Yeah. So because you want to estimate if there is a difference between the two population proportion, right? So if there is no difference between the population proportion, so when you subtract the two population proportion, and if there is no difference between the two population proportion, the difference will be 0. If there is a difference between the two population proportion, then the difference will be some other number. So that's why the idea for the conclusion of the hypothesis, we're going to take a look at the confidence intervals and compare with the 0. So performing a two-tailed test hypothesis for the confidence interval. So you might base on the answer for the lower bounds and the upper bounds, so we can get the same conclusion for the two-tailed test hypothesis. So if the confidence interval that we constructed contains a 0, then we cannot say that there is a significant difference in the proportion. So if the interval has a 0, which means that there is a possibility that the two population proportion will be equal. That's why you cannot say that there is a significant difference between the two population proportion. If the interval does not contain a 0, we can say that there is a significant difference in the two population proportion. Yeah. So based on the answer for the confidence interval, you might get the same conclusion for the two-tailed test hypothesis. So compare the interval with the zeros. If the confidence interval contains a 0, the null hypothesis is true. So you cannot say that there is a significant difference in the two population proportion. If the confidence interval not contain a 0, then you might say that there is a significant difference between the two population proportion. There you go. So this is going to be the formulas and the shortcut that we use it to do the calculation for this confidence interval to estimate the difference between the two population proportion using independent samples. Okay. So let's give it a try for this question we have right here, everyone. Okay. So an economist obtained a random samples of 800 urban households and find out that 338 of them have internet access. He also obtained another random samples of 750 rural households and find out that 229 of them have internet access by a 99% confidence interval. So we need to look in for the 99% confidence interval for the difference between the proportion of urban households that have internet access and the proportion of rural households that have internet access. Yeah, the difference between the proportion of what? Of urban household that have internet access and then the another proportion of rural household. So we're going to compare two population proportion of urbans and rurals, and you want to see if there is a difference. Yeah, so if there is a difference between those two. Yeah, okay. So now let's do that. So I'm going to say that's assuming that all of the condition has been checked, right? So assuming that all of the condition has been checked, so we're going to just work on the construction of the confidence interval. So if you're going to take a look at the formula we have right here, right? We need to find out z sub alpha over 2. And then the calculation of z sub alpha over 2, you might go back to chapter 9, right? Because we're actually working on this. 3 critical values, z sub alpha over 2 already based on chapter 9. So you might take a look at that calculation again in chapter 9, or I will show that again then, okay? So in order to find out z sub alpha over 2, you're going to start it from the confidence levels. And what's the confidence level then? So the confidence level we have right here is going to be 99. Okay, so the confidence level is 99%, which is 0.99. So after I got the answer for the confidence levels, I will find out the corresponding alpha, right? Okay. So alpha will be 1 minus the confidence level. Yeah. So which is 1 minus 0.99, which is 0.01. Okay. After I got alpha, now I will divide it alpha by 2 because we're looking for alpha over 2. So we're looking for z sub alpha over 2. So that's why we have to divide alpha by 2. 0.01 divided by 2, that will be 0.005. Okay. Now I'm looking for the z sub alpha over 2, right? So z sub alpha over 2. That's going to be, we just know alpha over 2, so I'm going to substitute that. So z sub 0.005. So based on the definition that we learned from chapter 9, z sub alpha over 2 is going to be a critical value such that the area to the right of this critical values is 0.005. So this is going to be the area to the right, and you're looking for the critical value z. So we're going to use the inverse norm, INV norm. And then when you're using the inverse norm, you have to show the area to the left. And this alpha over 2 is the area to the right. So if you want to show the area to the left, you have to do 1 minus that area to the right to get the area to the left. And this is the standard normal distribution. The means of zeros and the standard deviation equal 1. Okay, so this is the work that's how we use it to calculate these z sub alpha over 2, the critical values of the standard normal distributions. So we're gonna go second verse to accept the inverse norms, and then the area will be 1 minus 0.005. And then the means of zeros and the standard deviation equal 1. And this is going to be the area to the left. And we're going to get the answer is 2.5758. So this is going to be the critical value, 2.5758. Okay. So that's what we need to know, right? Now for the rest of the calculation of the lower bound, let's take a look. We need to know P1 has and P2 has. We need to know N1 and N2. So I think we know that already, right? Yeah. I'm going to go back to the previous example that we have earlier to get some of this calculation. Yeah. Okay. Okay, so from the previous calculation, we know that N1 is equal 800 because we selected 800 urban household, and among that, we find out 338 of them have internet access. So X1 is equal 338. And then for the second sample, we selected 750 rural households, so N2 is equal 750. And we find out that 292 of them have internet access. That's going to be N2. So based on that given data values, we know N1, N2, X1, X2, right? So now we just plug into the formula to calculate P1 hat and then P2 hat. Now, after we got the P1 has, P2 has, N1 and 2, now we are ready for the calculation of the lower bound. Okay, let me copy the formulas. Yeah. This might be a lengthy one, right? Okay. So this is the calculation of the lower bound. Okay. Now let's do the substitution then. So P1 has equal 0.4225 minus P2 has 0.3893 minus the z sub alpha over 2, which is calculated 2.5758 times it by the square root of a fraction, okay, plus another fraction, okay, yeah. So this is going to be P1 hat. So P1 has equal 0.4225, 1 minus 0.4225 divided by N1 was the 800. Okay. And then we're going to go on P2 has 0.3893, 1 minus 0.3893 divided by 750. Okay, so that's how we substitute the value, right? So this formula is kind of lengthy, right? So be ready with this one. Let's give it a try. Let's see if we can use a calculator to get the answer of this then. Okay, so we're going to get parenthesis 0.4225, take away 0.3893 minus 2.5758 times it by the square root of 0.4225 parenthesis 1 minus 0.4225 close the parenthesis divided by 800 plus now again 0.3893 parenthesis 1 minus 0.3893 close the parenthesis divided by 750. Oops, that's a long one. Okay, now let's hit the enter key to get the answer for the lower bound. Okay, so it's gonna be negative 0.0310. Okay, 0.310. So that's gonna be the answer for the lower bound, negative 0.0310. Okay. Good. That's done with the lower bound. Now, similar idea, we can get the answer, the calculation for the upper bound. Okay. The calculation for the upper bound, we're going to take the point estimate plus the margin of error t. So I'm going to change in the subtraction right here, become addition. And then I'm going to use a calculator to get the answer there. Okay. Okay, so in order to copy the previous calculation, you can hit the second and then the enter key. They're going to copy the previous entry that you just have it. And then you're going to go back to the subtraction in front of the 2.5758. I'm going to change in that subtraction, become addition, and hit the enter key one more time. Okay. So the upper bound going to be 0.0974, 0.0974. Okay. 0.0974. Okay, so that's how we just got the answer for the lower bounds and the upper bound, right? So let's double check the answer with the shortcut then. So this is the work that we showed to get the answer for the lower bounds and the upper bound. For those of you who enjoy the shortcut, you just give me the name of the shortcut and then the value that you use it for the calculation, and then just quote the answer from the calculator. That's also good. Yeah. Okay. Now let's take a look at the shortcut that we have it for this confidence interval to estimate the difference between two population proportion then. So we're gonna go to the stats option and we're gonna go to the test, and then we're looking for two proportion Z interval. Okay, so this is going to be option B, is everyone. Two proportion Z interval, option B. Two proportion Z interval, option B. Now, X1 is equal 338, N1 is equal 800, X2 is equal 292, and N2 is equal 750. And then the C level that we're using gonna be the 99%. Yeah, so you can put 99 or you can put as a decimal 0.99. One or the other, they should be fine. So in terms of a whole numbers, is 99, or in terms of a decimal, 0.99. Yeah. And then we go down to the calculate. There you go. Okay. So this is gonna be the answer from the calculators, and we're gonna compare with these one that we just calculated, right? Okay. I hope that's going to be good enough, right? Okay, so based on the calculator, we have the lower bound is negative 0.0311. We have negative 0.0310 because we just have the rounding error. And then for the upper bound, we have 0.0974. The answer also 0.0974, Okay, so that's good. Yeah. So if you're gonna use the shortcuts, everyone, once again, make sure that you give me the name of the shortcuts and the value for the input that you use it. Yeah, okay. So you just give me something look like, oh, I'm using two proportion Z interval. And then after that, you just give me the value that you use it for the calculation, right? So after that, we just give you, just show me the value for your calculation. So this is the name of the shortcut. So for those of you who using the shortcut, this is your work, you need to show it, right? So give me the name of the shortcut. And after that, you just give me the input that you use it right here. So X1s, N1s, X2s, N2s. And don't forget, this is the confidence level. You have to give me the confidence levels as maybe 99. Okay. And then after that, you just quote the answer from the calculator, right? So what is the answer that we have earlier? Yeah, so I will just copy this again. So the answer for the lower bound from the calculators is negative 0.0311, and the upper bound is 0.09741. Okay. So for those of you who are gonna use a shortcut, this is gonna be your work. You don't have to copy the picture. Just give me the name of the shortcut, give me the input that you use it for the calculation, and after that, just quote the answer from the calculator. Okay. Now we're gonna do a little bit further analysis. If you're gonna use in this confidence interval to get the conclusion of the hypothesis for two-tailed test, right? So when you take a look at this confidence interval, now, let's do the interpretation first, right? So we are 99% confident that the difference between the two population proportion of urban households that have internet access and the proportion of rural households that have internet access is between the lower bound, negative 0. Equal negative 0.0311 and 0.09741. Okay, so between the lower bounds and the upper bound. Okay. Now, when you take a look at this confidence interval, you might use in this confidence interval to get the conclusion of the hypothesis for the two-tailed test, right? So if you're gonna take a look at this confidence interval, the lower bound is a negative numbers and the upper bound is a positive number. So which means that this interval has a 0, right? So this confidence interval contains a 0. Because the lower bound is a negative, the upper bound is a positive. So when you go from a negative number to a positive number, you have to pass a 0. That's what I mean by the confidence interval contains a 0. So since the confidence interval contains 0, which is the number 0. Yeah. So because there is a zeros in this confidence interval, you cannot conclude that. Yeah. You cannot conclude that the proportion of urban households that have internet access is greater than the proportion of rural households that have internet access. Yeah. So once again, because this confidence interval contains a 0, which means that there is a possibility that the two population proportion will be equal. If the two population proportion is equal, which means that the greater than claim that they say greater than proportion is not going to work. So that's why you cannot say that the proportion, yeah, so you cannot say that the proportion of urban households would have internet access is greater than. So that's not good. Yeah. So or you're gonna fail to reject the known hypothesis because this confidence interval contains a 0. So you fail to reject the known hypothesis. Yeah. So once again, based on the answer for the confidence interval, you might have the conclusion for the hypothesis that we have earlier. If the confidence interval contains a 0, you fail to reject the known hypothesis. If the confidence interval not contain a 0, then you reject the known hypothesis. Okay. So this is gonna be the second objective that we learned on this section, which is the inferential statistics about two population proportion using two independent samples. And then we talk about the calculation for the confidence intervals. Okay. So we just complete the second objectives or the second half of the inferential statistic about two population proportion using two independent samples. So you might stop the recording at this point, everyone. And then now you are ready to complete the homework for section 11.1. I will see you next time for the next recording. Yeah.